Think of this video today as more of an overview than a review of the MSI MEG X670E AIC Slots and Storage PCI Express resource allocations. We're going to need to go over three things: the motherboard, the CPU, and the chipset, as we try to look and determine the difference in design versus implementation. So motherboard, CPU, and chipset. We're going to have three add-in card scenarios that we typically do because by default, 3 slots, 4 M.2 drives, plus the expander card, which leaves us with 4 add-in card possibility scenarios. And because of that, we're going to have to look at 4 add-in card possibility scenarios for this particular motherboard. So we're answering a subscriber question from Joey, and I want to thank Joey for making this video possible. We've got more information than we normally would have, plus we have some extra questions. Since this is now our 4th X670 Extreme motherboard that we've looked at based on questions and things you guys have asked about. Right now the list is probably about 7 motherboards because of the questions. We're working through them. It takes time because this overview is all about resources. We got to figure out what's what so we can decide if a motherboard we like versus another motherboard. Now, again, to reiterate, based on the ones we've looked at, I agree and I concur with Joey on this particular motherboard. I like the way that resources are allocated. But because of that, there's some things you got to look at, what we talk about all the time. And as we look at and we establish, because we're talking about a consumer desktop motherboard, we're going to relate that to technology from the high-end desktop and the workstation that has trickled down from the server platform to that. And the machine in front of me is the machine we reference, which is in the middle, which is the high-end desktop, which has kind of gone flat, but may be coming back based on some stuff we said in the last video. I won't get into that, separate topic. I want to try to keep this short. Because of the technology that we're looking at, it's trickled down, my concern is based on this motherboard platform, on this chipset, and it's going to matter as we look at chipsets, this technology is not being translated up to the high-end desktop or the workstation. Because when we're talking on a consumer desktop motherboard, this is about limited resources. And what we have to have for the first scenario we're looking at, 2 things. One, we have to have a 16-lane slot, which we have. So what we're going to look at are CPU PCI Express resources and chipset PCI Express resources. The second thing we have to be able to do is bifurcate the slot, which we can do on this motherboard. But how those 3 slots are allocated, and yes, all 3 of these are the CPU. That's why we're going to go through the scenario of either 3 or 4 add-in cards because of the Xpander-Z that's included with this, which is PCI Express 5. But in actuality, that's more like a dual adapter, a dual M.2 NVMe adapter. Happens to be PCI Express 5, and everything still right now is PCI Express 4 or PCI Express 3. So we've got these options we want to walk through. So as we look at the motherboard, CPU, and chipset, let's start with the motherboard. And the first place we're going to start is not the overview, but we're going to go to specs. And starting at the top of the list, this supports the Ryzen 7000 processor, and that matters. We're going to look at the specs on that. This will support 4 gigs of DDR5. And I need to interject as we come to these items, because even though this is overview, not a review, when we're talking about DDR5, but this question actually goes, it's like a 3-part that I want to deal with while we're here. What's the least amount of memory you can put on one of these motherboards? From what we've been able to ascertain, you can go with 1 stick of memory. And I'll show you when we get into the block diagram, because 3 things we need to look at in the motherboard manual. The motherboard layout, or the overview, the block diagram, which we have in the new manual. If this information was any fresh, we'd have to slap it. As a point of reference, Joey found this in the latest manual when he updated and downloaded that, which kind of blew me away. And referring to page numbers in this manual is absolutely no good. What we have to refer to in this manual when we get to it is going to be according to the topic. Topic number 1, overview or layout, block diagram, specifications. Those are the 3 key items. Now, 2 other areas we're going to be looking at, anything with shared resources or anything where resources might be something as we look at the division being slots first and then storage. When we get to storage, that divides from an M.2 NVMe to a SATA drive, and I'll get into that. So that's why I'm going to start at the top, and as we come to it, we'll deal with it. And again, we want to keep this short and keep it tight. So to reiterate, check the RAM. I'll have a link up on this into Kingston so you can look at this and reference this. And to reiterate, when we get to that, I'll show you. Dual channel, so 4 slots, supports the AMD Expo. No mention of the XMP. Non-ECC unbuffered. Okay, one of the new technologies we're going to see is Displayport. So again, I need to interject. This is MSI. Something you're not going to see. One of the things we cover, which is Thunderbolt. No Thunderbolt on this chipset with these motherboards. because as we get into the motherboard manual and we do a search for certain things, there's no mention about Thunderbolt and there's no mention about USB 4. So those are things that are not going to happen. But of the three technologies that USB-C can support, which is data, power, and USB-C DisplayPort alternate mode, that is supported, but that is a technology in the CPU that I'll point out when we get to it, that is now pointed out here in these specs that we're going to reference. So we're looking for congruent information as we go back and forth with some of this stuff. So some things we may look at more than once. That's why I like to start when we get into the manual with the motherboard layout. I like to see where everything's at. And out of that USB-C port, understand that'll be 4K 120 Hz, which is pretty incredible. Available only on processors featuring integrated graphics. Graphics specifications may vary depending on the CPU installed. And to reference the 4 CPUs that we're going to be looking at, will all support this. Okay, now for slots and storage. First of all, 3 slots, by 16, 0 by 4, by 8 by 8 by 4. What that means is the PCI Express _E1, all 3 of those, first of all, are PCI Express 5. But the first slot, second slot, and the third slot are all from the CPU. And the 16 means that first slot used by itself, which we will reiterate when we get into the block diagram because it all makes it really understandable and really simple to comprehend. To reiterate, that first slot is a 16-lane slot used by itself, which means it's 16 lanes mechanically but also electrically, which means, because I've had this question come up about what's the difference, well, you can have a long slot that's 16 lanes or a by 16, but if it doesn't have 16 pins up in there to connect, then it's not going to get 16 lanes transferred to that device. So to reiterate, because those 2 slots, which happen to be shared, and that's what this indicates, that we get 16 lanes on the first slot, the second slot, when used simultaneously, they each have 8. Because as we look at CPU lanes, we're going to have 3 numbers we're looking at, a total that I come up with, but then we have a usable set of lanes that are identified by AMD, and then the total lanes that are identified by AMD, which is a different number than what we identify. And remember, we have a CPU and we have 2 chipsets, or 2 chips that make up the chipset. So with the CPU, there's a total amount of lanes, which we come up and consider the source of 32. And then what the other parts you have that we're counting right now are usable lanes, which will be 16 plus 4, and on this chipset plus another 4, so that's 16, 20 plus 24. And the total they come up with is 28. The 4 they don't account for are the lanes that connect the CPU to the chipset, which are PCI Express 5 lanes downgraded to PCI Express 4. So that's how we get that total count. But how all those other lanes are accounted for, I never tried to count all the lanes until we got to this chipset because of my curiosity. I'm always off a lane or 2. Sometimes I'll get 30, sometimes I get 31, sometimes I get 32. It depends on how they're allocated. So we're going to focus, to reiterate, on what AMD gives us, but I'm telling you what the total is based on what I've been able to come up with. And how they're allocated to this slot, the fact that these 3 slots are all CPU. On the other motherboards we didn't have it set up like this. But because the slots are set up like this, when we start getting into who's going to be on first, who's going to be on second, who's going to be on third, all that matters. Because a lot of times on this third slot, we didn't have 4 lanes allocated. We had 2 lanes. And for most add-in cards, for whatever you're going to do, you need 4 lanes. And even though it's a 16-lane slot, to reiterate, mechanically, electrically, that third slot is 4 lanes. So I want that distinction clear because we're going to come back and reference this, but we may not look at it from here. We'll reference these same specs that are on the website with what's in the manual. It's the same information. But I want to go through this, and as we hit it, I want to cover it because I'm hoping it'll help you to understand. We get a little bit of information from this, but we get a lot more information from the manual. Okay, supports AMD Multi-Gpu. That's another issue that's come up because of the RTX 4000 series. Okay, if you put one video card on here, you're going to be fine. But because of what's going on with the RTX 4000, which is still PCI Express 4, the only thing that's PCI Express 5, which is actually ATX 3.0, is the power tap, which has 30 times for an insertion for that electrical connection. Okay, because on the RTX 4000, the reason I'm mentioning this now, the number one reason, is NVLink is not going to be on the consumer cards. Now, I have I've had somebody ask me about how this is going to be on the professional cards, and there's not enough information I can show you a link that tells anything to the degree of the specs we're talking about with slot width or lanes being used All we know is PCI Express 4 on the RTX 4000. What we don't know is some of the things I'm talking to you about now. We do know, to reiterate, on the consumer card, no NVLink, but we don't know on the new RTX, whatever it's going to be, Pro cards, it looks like those still support NVLink. And if the technology is being removed, I've got a link I'll put up in the description that shows for the Pro cards, it's there. And when we're talking Pro cards, I'm not talking about AMD. I'm talking about the NVIDIA cards, because those of you that are wanting to use, let's say something like 3ds Max, this is a consumer motherboard, I wouldn't use it for that, but if you did, this could be used as the second machine, which would be the editing machine or the manager, not the render machine. For the render machine, I want to be something up here higher, high-end desktop or a workstation. But if you want to put this in the mix, not for a high CPU core count, but for fast CPU cores, which you need, this fits that. But if you want multiples of fast CPU cores, then you need to be looking above that. So I'm referencing some of this stuff because anybody that's using something like an RTX 4000 that's using 3ds Max might be using NVIDIA Omniverse. And so if you're using NVIDIA Omniverse, you need that technology for that capability. Back to the specs, which would be NVIDIA. And we've always focused on CUDA cores. Now, 4 M.2 slots. Here's another key feature. Okay, typically we reference the machine in front of me, which is the high-end desktop, where we reference 2 M.2 drives to the CPU, and we have 2 more M.2 drives through the chipset. In this situation, it's different. We have 1 M.2 drive to the CPU because it's PCI Express 5. Anything to the CPU is PCI Express 5. Anything through these 2 chipsets and below is going to be PCI Express 4 and below. Could be PCI Express 4, might be PCI Express 3. Depends on how it's allocated. Well, we don't get that much detail in the block diagram, but we get enough to know lane allocations. Okay, so to reiterate, 1 PCI Express 5 and 3 that are PCI Express 4. And we have 6 SATA ports. So we'll split that out as we get to it because there's some issues there. And as we notice down here below that, it supports RAID 0.1 and RAID 1.0. Notice here, and this has also come up, the 2280 and the 2260. That number 1 will support those formats. 2280, and I don't remember who brought this up first, was about the width, because you've got 2 dimensions. You've got the width and you've got the length. Okay, the format for 22 is 22 millimeters wide and 80 millimeters long. Okay, there's another format that may be 25 millimeters wide based on PCI Express 5, but we haven't seen any of those drives. But since none of those drives are out at this time, all we know is what we're finding out as we get into this. And I say this because, again, to reader, it's come up. I'll get a link up in the description about this issue. So what we have to do is rely first on what the manufacturer says, what it supports. And it's important as we get to the Xpander-Z card, which is not listed here, that will support 2 M.2 drives of the format, and I believe it's 22110. No mention of the 25 millimeter width. And that width can be an issue when you put 2 drives side by side about having enough room for that space. That's why I want to mention that. So we're gonna go with what they say and what they tell us here, and we'll double check that when we get into the specs in the manual. Now, the manual we're showing you is the manual that's current as of today, but you know, change one thing changes everything. As we have seen the manual's been updated, the manual could be updated again with new, more current information. So anything we share with you, consider it, take it for a grain of salt, always test and verify and consider the source. But we want to share with you and show you what you're looking for so you'll zoom in on that. One of those little things that was right in front of you, but unless somebody pointed out you didn't see it, now that you see it, you can't unsee it. Copious amounts of USB ports, and I find this quite extraordinary. To reiterate, there's no Thunderbolt mentioned of any kind, and there's nothing about USB 4. But what we do get, and we have a separate video about this, whenever you see the generation 2x2, that's dealing with the USB. Now, the way I like to refer to it is the speed, then the connector. The way the USB forum likes to refer to it is the USB, then the speed, but they don't identify the connector, which I think is kind of lacking. Some more obfuscation that kind of came out at the last minute when all these new motherboards came out. So to reiterate, what you're looking at, what we define as a 20 gigabit USB-C port, when you see generation 2x2 as a motherboard manufacturer defines it, that's a 20 gigabit port. USB wants that referred to as USB 20 gigabit. So you're going to see specs that say USB 40 gigabit, which is USB 4, USB 20 gigabit that we're talking about, USB 10 gigabit, and then USB 5 gigabit, and then the other stuff below that. But as it relates to USB, it's always USB first, then the speed, but doesn't give you the connector. So when you're talking USB-C versus USB 3, that's usually a 10 gigabit port. Then you have to look at whether it's talking the Generation 1 Type A, Generation 2 Type A. It's we're going to look at the I/O panel and kind of simplify that. But lane allocations matter as we try to group all that together, because the first thing we deal with for slots and storage are how those usable lanes are allocated. Then this kind of stuff with USB comes into play when we talk about the other lanes, which are the total. So we go from 24 to 28. And the other lanes, to reiterate, we're talking about are those other 4 that go down, connecting the CPU to the primary chipset. And then you have the secondary chipset connected to the primary. Now, when we talk about the 2 chipsets with lanes, chipset lanes, these two together, we get 32. That's just by our count. The numbers that are talked about by AMD are 8 or 12. And I'll show you what AMD says. We have a link from another article that talks about in the primary chipset having 8 usable lanes, and in the secondary chipset having 12 usable lanes. Well, you can add those up pretty quick, see where that goes. So we'll focus on the usable lanes, but I'm making you aware of what they call total lanes and then what we're calling actual total lanes. 3 numbers, 2 numbers they give, the third one's ours, so consider the source. But how that stuff's allocated matters, because we're getting ready now to talk about 10 gigabit. And I can show you information on the specs, but again, to reiterate, to keep this tight, Marvel AQC 113, which that should be PCI Express 4.0, 4 lanes. If that's the way it's allocated, then you'll keep that in mind when you do that, running the numbers. Now, this AMD Wi-Fi, as near as we can tell, based on feedback from other subscribers and viewers, that looks like just what it says it is. MSI is using it right now, the AMD, and I'll get a link up to that. I believe it's the AMD MediaTek chip that they developed previously before this came out. And another curious thing, since we're talking about extra chipsets, typically when we want our Wi-Fi, and it's not so much for the Wi-Fi but for the Bluetooth, for connectivity, we want that to be an Intel chipset. So on your Wi-Fi, and that is a standard plug-in M.2 connector for the Wi-Fi using 1 lane. But if you wanted to change that out, we did that once on an X399 motherboard. Man, was that trouble. I did it. Don't ever want to do it again, but when we did it, we had to then slipstream the drivers into Windows so that Windows would install. Otherwise, Windows would be SOD, and everything everybody said was like this. So you can do it, but we had 3 layers to deal with. We had the motherboard, we had the back plane, and then we had all that I/O cowling on the front. And I know we had 2 separate types of screws, but there were 3 layers of screws through all 3 layers. But I don't remember if it was 2 types or 3 types of screws, but it was a big deal. It was a hassle. Did it once, won't do it again. And if you're using this for a digital audio workstation, everything I've just said about the Wi-Fi, that's the first thing you want to turn off because of DPC latency. So, change one thing, changes everything. And I always talk about listing your 5 requirements on a motherboard. What are your priorities? See if you can live with those 5 priorities and see how that goes. And that's what we're doing when we're talking about slots and storage, lane allocations for CPU and chipset. Back to the specs. And every one of these motherboards is different and absolutely fascinating. And to reiterate, I think this has the best allocation of resources of all of them. We were really disappointed in the resource allocations as we saw it and identified it according to our needs for content creation and rendering as we looked at this on the Asus ProArt. Realtek audio. If you're using this for a digital audio workstation, you don't care about that. You'll plug in your own, probably USB-C. I'll reference that when we get back to looking at the block diagram. Power connectors. Now, this is important, and this says here front type power. Okay, want to deal with each one of these issues as we come to it, because trying to come back, I think, would be confusing. When we look at the motherboard layout, block diagram, and the specs, which will reiterate this, that connector is going to be a connector to the front of the motherboard, which is the orientate the motherboard from north, south, east, and west, west being where the I/O connector is at. As we look on that edge to the front, you're going to have your USB-C connection, which I'll reserve saying what the speed of it is when we get to the connector. But you'll see another connector right by it for power, to get power out of that, to get that up to 60 watts, because that's part of the USB specs that the USB Independent Forum is dealing with. Not only speed, but also speccing out for power. And cables, I'm not a fan of USB-C because of the cables. If you got a smartphone, you know where I'm coming from, you've dealt with that. So to reiterate, this is a power tap, which historically an extra power tap was a PEG connector, which was PCI Express graphics, to get extra power to the bus. This is a power tap to get extra power out that USB-C port that goes to the front. So if you want to know what kind of case you're looking for a case that'll have a USB-C port on the front. And I didn't realize till I was doing this, when I was going back looking at specs, because somebody asked about resource allocations for slots and storage, how long have we had USB-C? We had USB-C, as far as I can tell, back to 2005, so for about 5 years we had a port we couldn't do squat with. Never did use it. And I didn't realize it till I looked on the motherboard and said, oh, I remember that. And I remember not using it because we didn't have anything. So now we need a case that's got that port on the front, and that's a good reason for it. These little things matter if you're doing it. If you're not doing it, it doesn't matter. One other connector that I'm going to mention, actually two. The thermistors, there are two thermal sensors on here, but the primary reason for this is the tuning controller connector. That connector is on the motherboard, but the MSI tuning controller device is not in the box. And I have not seen anywhere where you can buy one separately. So this is clearly targeted and marketed to a motherboard owner who's had an MSI motherboard in the past, like one of the MSI Godlike motherboards that has that tuning controller. And yes, you can take that tuning controller and put it on this motherboard through that connector. But I've not seen, to reiterate, any place where you can buy that separately. I don't get what's up with that. So I want to point it out because I got an image. When we get to it, I'll show you that Joey sent me. And I appreciate Joey asking a question because this is answering a subscriber question, remember, and a few others as we've been asked as we go through this. But we're trying to keep this tight. And everything we're doing, to me, that's that tuning controller, I call it tinkering. And because of what Joey does, he has set some world records with his tuning. I hope this will perform to his satisfaction and he doesn't blow it up. But that's another issue. We're always about content creation rendering, and that's the approach that we're using on this because that's how he came to us. All these USB ports, and you'll notice here there is, again, we're looking at connectors. And on these connectors, we have a USB 2x2 and a USB 2x2. And we'll go over those again when we get to the block diagram. Because a USB 2x2, 20 gigabit USB-C is using 4 lanes. Whereas the 10 gigabit would be using 2 lanes. Back panel ports. This is the first indication of some interesting things. We're going to focus on one thing, 3 ports. Number 8, 9, and 10. That is 3 USB-C ports. This port is an optional port because of the way it's configured. These 2 ports you're going to be able to use all the time. What do I mean by optional? It's a shared resource. That is a USB-C 2x2 20 gigabit port. And that's relevant to 2 reasons. One, it's a separate chipset, which is kind of cool because there's actually 3 AS Media chipsets that do 3 different things that we're going to cover when we get into it. But for the purpose of this right here, the second reason is because that's a shared resource. It's a use that or use this, but you can't do both. So that's an optional connector, and that's what I want to point out. The other 2, though, are not shared. They're dedicated. To reiterate, number 8, which is up there on the angle, is a 20 gigabit port on an AS Media chip. 9 is a 10 gigabit USB-C port, and that's where you'll get Displayport out of, which means that's tied to the CPU, that's CPU lanes. And this other 2x2 port, 20 gigabit, that's probably a chipset, but we'll verify when we get there. Typically what we've seen, which is different on this motherboard, you have, again, your CPU and then your 2 chipsets, and you'll have USB-C out of each one of those 3. Typically 10 gigabit up here, 20 gigabit, and 20 gigabit down here. With this motherboard, a little bit different because we're using CPU lanes, not directly coming out of the CPU for 20 gigabit, but to reiterate, we're using CPU lanes to get 20 gigabit. So 4 lanes allocated for that. And we still have the 10 gigabit that gets video out. Now, the issue with the 3 things that USB-C can do, because of this spec that I'll show you when we get to the specs on the processor, based on the Ryzen 16 core for this motherboard, USB-C out of the CPU, you're going to get typically 2 or 3 connectors. Let's go back and take a look at that while we're at the I/O panel. And if you'll notice on this I/O panel, we don't see an HDMI out, we don't see a DisplayPort in or a DisplayPort out. To reiterate, if this had a DisplayPort in connector like we had on the previous motherboard, which was the Asus ProArt, I believe that was the Asus ProArt X670E Creator Wi-Fi. Anyway, it had a DisplayPort in, which means that would allow us the ability to route video out of a video card back into the motherboard so we could get video out. But that motherboard had that way because it had Thunderbolt 4. We don't have Thunderbolt 4. So the only video out we have on this motherboard from the internal GPU, which is 2 cores, which is fine for wanting to get the resolution to see something, but we've only got 1 internal connection coming out, which is coming out of that number 9 port for USB-C DisplayPort alternate mode. So typically where you had 2 or 3 monitors to support with the internal GPU, on this one we support 1 monitor with the internal GPU. If you want to support more than 1 monitor, that's what your external video card is for. That plays into these scenarios as we talk about these add-in cards that we're going to get to. I'm taking a little bit different approach with this motherboard. I want to be more thorough, and this is based on the questions that we've had to get to this point. Okay, that's what's significant on the I/O panel. Supports Windows 10, Windows 11. The form factor is EATX, so you want to keep that in mind when you're looking for a case. And it goes through a description of box contents. Now, while we're here on this, there's 2 points you need to think about. One, when you receive whatever you've ordered, put a camera on it and videotape it for 2 reasons. One, you want to make sure that what you received is what you've ordered. That's an issue, that's a separate topic. And number 2, you want to inventory your parts, because if anything's missing, that's a deal killer, because you're going to have to RMA the board. If you're trying to get parts for something, they don't sell the parts, they sell the motherboards as a package. That's the easiest way to deal with that, so that's what they do. So you want to verify that stuff. Those 2 things as you're watching over that. Want to point that out. And I hope this information helps those who have built and those who have not built but are considering it. Now let's go back up, swing over to support, and get into the good stuff. While we're here, we're only seeing 1 BIOS, which I'm kind of surprised. BIOS, we usually update 1 of 3 things. And depending on how the motherboard's configured, again, since we don't have Thunderbolt, that 3rd thing would be a firmware update, which is not there. But the first thing would be for RAM compatibility. The second thing would be a GISA code for the same reason, for compatibility, which updates the microcode in the CPU. 1 BIOS, I've seen other motherboards that have had information out longer than this that already show 3 BIOSes before the motherboard even shipped. So if you're having issues with compatibility with RAM, stick to the QVL, which I'll get to more in a bit, and watch your BIOS updates. You want to be sure and get that done, since this is a new platform. And that says that's a beta BIOS, so you want to be careful with beta BIOSes. In other words, if it ain't broke, don't fix it. But if you're having issues and you got to fix it, get it done as soon as you can, because if something happens and something goes wrong, you want to be able to RMA it. And you got that 30-day window to deal with. We had hoped by looking at drivers, we'd be able to figure out what's going on with the LAN, and that helps to reinforce AMD Wi-Fi drivers, which tells us that's the AMD MediaTek chipset, and the 10 gigabit Super LAN Marvell chipset, which they're now showing. What we want is the manual, 1 manual multi-language, and it's pretty big, nearly 40 megabytes. And this manual is like 582 pages. I've looked at it on a computer and on a smartphone, and it takes a bit of time to cache on a smartphone. So first thing we're going to do, if this will work, we're going to go to Contents. And that's why I can't refer to pages on anything in here, because none of the page numbers line up with what we're used to with everyone else. Okay, Contents. We're going to be looking at specifications, and there's no mention in this content description about the block diagram, which is a big deal to know where everything's at. It really helps to zero in and figure out what we're doing. It's near the end of the manual, and Joey was the one that found it and pointed out, because I've been making a big deal about it. So we're going to get to it. But it's, to reiterate, not under Contents. You'll have to do a search for block diagram to find it. Everything on here, you've got to do a search according to the terminology. That's why what we have in the description will be the terminology you want to look for to find the things that we're pointing out that we think matter. Because you need to do an overview on a motherboard before you even think about doing a review on a motherboard. Because otherwise, I think you're spinning your wheels and wasting your time. So we hope this is helpful. Okay, to reiterate, specifications, block diagram, back panel connectors, and we'll reference that again. And then the overview of components, which we also call the motherboard layout by everybody else's definition. And something we'd like to see is they lay out the manual a little bit differently, but I understand where they're coming from. Okay, from the top down, we don't get a good indication of chips, but we will have a good indication of connectors. First things first, we have 3 slots: PCIe_E1, PCIe_E2, and PCIe_E3. And all 3 of those slots are to the CPU. And we're going to look at those resource allocations. A 16-lane slot, when used with a second slot simultaneously, that both become by 8, because that's 16 lanes you have to split. And then the third slot is allocated 4 lanes. So because we have an allocation of 16 plus 4, which is 20, our M.2 drives, right here is M2_1, over here by the RAM. And Joey and I were talking about this. One of the nice things about this slot, because of where it's located, you have the option, if so desired, because we looked at 14 different heat sinks and 3 different thermal pads, different video. But to reiterate, you could put an optional heatsink on here because you have height and you've got, I think, enough width clearance where it'll clear. The issue that Joey got into with clearance where the RAM backs up because of the connectors with that first slot. That was pretty tight, which was a little bit tough, as he said, if the backplane on your video card, your GPU, is a little bit thick. And I believe he was using an RTX 3090. I'll show you as we get to it for some images. And then the other M.2 connectors, M2_2, right up here, M2_3, and M2_4. And we've got to look at the issues, again to reiterate, of how these resources are allocated. The connectors we're going to focus on are up here on the right side, from the top down. And right there's the power delivery we talked about, which is right next to the ATX 24-pin power. And that power tap is for that. And there's the J USB 2. So that's probably a 10 gigabit, and that's probably a 20 gigabit. And then right here we have a J USB 3 and a J USB 4. Those are the 19-pin connectors for the USB 3 2-port and 2-port to the front of the case. From here, let's go take a look at the specifications right quick. See if anything's any different. CPU, which we're still going to look at. Chipset, we've still got to look at. 128 gigs of memory. I've said my piece on that. And again, if I was doing this, I would probably use Kingston. I believe Joey was using G-Skill. And based on G-Skill, I expected that to be Samsung B-Die. But of the three types I mentioned, I didn't mention the names, Samsung B-Die being the best. Also Micron, which is a big player. But the Hynix memory is what his G-Skill was, which I didn't expect. I was surprised. So Joey said he was going to try, because of what he's doing with the overclocking, to get some Samsung B-Die. If I can remember, somebody remind me, I'll put up a link in the description, but I don't want to get any more into that, other than if you're going to punch those chips to push them up, Samsung B-Die is what you want because it can handle it. So based on the Adobe After Effects multi-frame rendering CPU optimization formula, deals with three numbers. It's all about the quantity, CPU cores, amount of RAM, and the amount of video RAM. So number one is CPU cores times 4. So if you have a 16-core CPU, 64 gigs of RAM. That's where you'll get to that. And the issue we had had previously with the X570 on the AMD 5000, specifically the 5950, where if you used all 4 sticks, you took a performance hit anywhere from 10 to 30%. So you only wanted to use 2 sticks. So to reiterate, on this platform, with this CPU, with this chipset, you can use 4 sticks. You don't have to worry about a performance hit. So those of you that want to tinker and blow it up, you should be good to go. That's kind of, I think, where Joey's going to be headed with this. So I hope he reaches the record he's after. But the resource allocation on this motherboard is the best based on those slots and based on the storage, because the primary M.2 drive is going to be PCI Express 5. The other 3 M.2 drives can be, if used, PCI Express 4. And he's got the potential for 2 more M.2 NVMe drives, potential, on PCI Express 5. But we haven't even touched on the scenario for the add-in cards yet. But I'm going to get to it because I want to plant that seed. I want you to be thinking about it as we go through this with all these numbers. And if we, 2 ways to look at this. Number one, with RAM, as we get to this, think about the QVL, stick to the QVL. You're going to have to choose the speed you want to go with as it's identified, because based on the speed you choose, you're only going to be able to push it so far. And if you choose a higher speed, you're going with a lower RAM count. That's my point. So in the past, we could put 2 different kits. But if we read book and verse on what both MSI and both what the manufacturer, like Kingston, would say, they'll tell you, you want to make sure that you put all 1 kit. So when we get to the memory and we look at where you can put 1 stick on, if you buy 1 stick and put that on, just understand and be aware that if it doesn't work with 2 sticks because they're separate, because they're not matched, because they haven't been tested at the same time, understand why. This is the party line, and what you're wanting to do is what we used to do. But because this is PCI Express 5 and it's a new platform with compatibility issues, be forewarned. All these details matter, and I got to tell you, dual channel, and if you need more RAM, then you want to go with something like a high-end desktop or a workstation. Okay, how long have we had dual channel? More than 10 years. Then we had the triple channel. Then we had the 4-channel quad, and that's what you get on the high-end desktop. Then we have the 8-channel RAM when you go to a workstation. But you're talking for those 2 versus this down here. This down here is PCI Express 5. These 2 here are PCI Express 4. So you have to consider those things. Personally, because I'm looking at more CPU cores, this platform right now stops at 16 cores. If I want more CPU cores, then I'm looking at something else, high-end desktop or the workstation. And the workstation, based on not CPU cores, which can be apples and apples, but I like to think of it as apples and fancy apples, I can go from 16 cores to 32 cores. And instead of counting CPU lanes for the price per CPU core, I like to count, again to reiterate, CPU lanes, which is based on their number of 28 lanes versus 128 lanes. So you do the math on that, and that really makes things look different, because it makes the two 16-core 28 lanes versus a 16-core 128 lanes and an interesting price point, but that you can take that to 32 cores or 64 cores. Yes, you can use less, but for the numbers I'm talking about, just something to think about. There's always more than one way to look at things. The reason we started doing that is because used to, when we looked at drives, it was always about a price per megabyte. And that's how you figured out which drive had the best price. So that's two ways to look at a CPU core when you're trying to figure out best bang for the buck. Motherboards in this consumer area of around $500 versus a motherboard that's twice that price, versus a CPU, for round numbers, that's going to be more expensive, but it's going to allow you more growth. The consumer desktop motherboard, you probably got about a 2 to 3 year platform. For those of you that get 5 years out of one of them, my heart goes out to you. You've done well. But for those of you that need more processing power, there's other options. Back to the overview. Okay, we know the slots. Here's where we start hopefully finding some of the nitty-gritty. Still didn't identify it. We'll get to it. 6 SATA ports. Okay, SATA ports are through the chipset. SATA ports are low priority. SATA ports are 1 lane each. 6 SATA ports, 6 PCI Express lanes. Okay, here's an AS Media chipset. And this little detail here matters. SATA underscore P3, P4, and SATA underscore S3, S4. Those are from the X670 chipset. And these other two, SATA A1 tilde A2, are from the AS Media chipset. Okay, now why is that relevant? I'm going to look a little further down. I don't think it's mentioned here, and I'll tell you. But let's take a look. As we scroll on down, no, it doesn't tell us. It gets into the slots for M.2 connectors. Okay, this little detail here matters. As we look further in the motherboard manual based on possibly the chipset or the ports, we'll go both ways. What we're going to find are those 4 out of the chipset. Those 4 can be in RAID, which means those 4 can be in a hybrid BIOS bootable RAID from the boot, or they can be in an operating system RAID. These other 2, because it's on a separate chipset, 2 requirements. First of all, you will not be able to boot with those. You will not be able to put those in RAID because, number 1, they have to have a driver, and a driver implies an operating system. So they're going to work within Windows, but they're not going to work for this other stuff. So it's nice they're there, but they're separate, but they still use lanes. It's an interesting use of resources. SATA ports are nice, but SATA ports are not like they used to be. But they're there, and that's how they're allocated. So I'm going to point that out, and those are the requirements for usage. So now down to the M.2 connectors. And here where they point out the key. I don't like to get into the key issue. All I want to say is, based on the specs, these are M.2 NVMe PCI Express drives. These are not M.2 SATA drives. The distinction I like to make, which I think is a lot easier, our goal is keep it simple, make it work. You've got 2 types of M.2 drives. You've got an M.2 SSD, which is a SATA, and you've got an M.2 NVMe PCI Express, which is an NVMe drive. The big difference is 1 lane versus 4 lanes. Some motherboards with some chipsets on some connectors can go either way, but this one is very specific, the way those lanes are allocated and the way those connect. We had that issue when we built this Gigabit TRX40 Designator high-end desktop, where the specs said one thing, but one subscriber come back and said that second connector, which is to the CPU, only supports M.2 NVMe. Originally in the manual it said it would support an M.2 SSD, which it did not. And the reason he found out is because he had another machine. He'd pull the drive out and he wanted to pull the data off. He put it on that connector and it wouldn't work. He had to use a different connector. But anyway, I make that distinction here so we understand the difference. To reiterate, an M.2 NVMe SSD is what we're talking about. And everything SATA is on the SATA connectors. And it's the difference in 4 lanes versus 1 lane. Once those lanes like that are allocated, typically they're set in stone. Here it's kind of interesting, as it has been with every one of these motherboards in this class. Okay, 4 M.2 connectors, M.2_1 to the CPU is PCI Express 5, and the format again is 2280, no mention of the 25. M.2_2 is from the chipset. These other 3 are all through the chipset. There should be a note down here. They're all PCI Express 4, they're all 4 lanes. They'll go anywhere from 2260, 2280. Yeah, it looks like all 4 of them are the same. Yeah. And that last one could be a 22110, 2280, 22110, versus the other 3 that are 2260, 2280. Most standard M.2 NVMe drives that we're going to come across are 2280. Okay, here's one note on the RAID. The SATA A1, A2 do not support RAID function. Oh, that's right. The SATA A1, A2, that's the AIC Media chipset. Just wanted to verify. Change one thing can change everything. Okay, we've got the SATA A1, A2, does not support RAID, requires a driver, requires an operating system. Audio, I've said my piece about that. You'll want to use a separate audio interface. You know, used to we used a sound card, but a long time ago we started looking at options for professional audio interfaces that were outside the machine, and we had better luck. Right now it'd be something on USB-C on this machine. There's our LAN controller, and we can look at the specs on that. That's using 4 lanes, PCI Express 4.0. It's also fascinating which chipset that's on, but we'll get to that. Going on down, the AMD Wi-Fi 6E, and yes, the Bluetooth. And then here's the note about the USB power delivery, 60 watts on the PD Power 1 connector we talked about. So you know about that. Okay, front panel connector, there's a 2x2 20 gigabit port from the chipset. Okay, so the 10 gigabit port from the chipset is standard wattage. I think it's 27 watts. But to get the 60 watts out of the 20 gigabit port, wow. Okay. And then you've got your USB 5 gigabit, and that's another AIC Media chipset. I believe that's AIC Media chipset number 2. There's a third one in here. Then we got our USB 2 also through the chipset, which makes sense. And here's another comment about the JUSB 2 does not support USB 2 devices. That's good to know. And to achieve the USB power delivery of 60 watt fast charging for JUSB 2, the PD_Power 1 connector needs to be connected to the power supply. Got it. Fan connectors, 5 of those, nice. And looking again, there is the tuning controller connector. To reiterate, you got the connector, but you don't have the device. Bummer. And I've got some notes Joey had about a couple of 3 things he'd like changed with some of the buttons. We'll get to it. Hopefully we'll get to it. We're all about function, we're not about form, so we're not into the pretty lights. They do nothing for the function. Okay, back panel connectors, 20 gigabit, another AIC Media chipset, ASM3241. Now another chipset you're going to be seeing from AIC Media, which will be the 42, I believe it's the 4242. This, to reiterate, is the 3241. We can go look up that chipset. I'll have a link in the description that talks about resource allocations for that chipset based on design from the manufacturer. So we can take that information and line it up with what the motherboard says it's using and make some determination on lane allocation, which would be chipset lanes. Unless, as in this case, it could be CPU lanes, which is quite fascinating. So we'll get the skinny on that when we look at the block diagram. And all these copious amounts of USB ports. The new Voton I/O controller, it mentions the chip. There's going to be some stuff in this generic manual which kind of blows my mind, because the manual for the BIOS, when we get to it, is not generic to the X670 Extreme chipset. It's generic to the AM5 platform, so it covers all those chipsets, which kind of blew me away. So there's a lot of stuff you're going to see if you look in that BIOS manual about the I/O that we don't have on this motherboard, like a serial port and a parallel port. So I'm just throwing that out there. When you see it, it's kind of like, wow. The most important thing we need in the manual for the BIOS is about bifurcation. It's not called that, but I'll show you the terminology when we get to that point. We're just going through the basics for the system layout. And when I got the new manual that Joey told me about, I had to go through all this again because I want to make sure everything was still correct and current. It is. Now let's go to the block diagram, and you have to do a search for it. Takes us nearly to the end of the manual, and there it is. And according to the PDF manual, this says down here, this is on page 573. And there's a layout where you can see the CPU, chipset number 1, chipset number 2. Or, excuse me, primary chipset and secondary chipset. Or promontory 21 if you want to call it. And they call it chipset A. Let's focus first on the CPU lanes. And after going through the specs, we should be able to run this a little bit quicker. Okay, those 2 slots are shared. Primary or secondary. That's 16 lanes for those 2 slots. We have a third slot, which is 4 more lanes, but that third slot is shared with that USB 20 gigabit port, which is out the back. So you have to decide if you're going to use, and this is where we get into the 3 add-in card scenarios, which is going to be 4. Okay, first add-in card scenario that we're going to get, which is a big deal in the next build that we've been asked, which is which is a big deal in the next motherboard overview we're going to be looking at, which is on an ASRock. A user wants to know about adding a quad card. Okay, as it relates specifically to this motherboard, if we put a quad card in that first 16-lane slot, because number 1 requirement is a 16-lane slot, number 2 is bifurcation, full bifurcation, well, what does that do to the GPU? Because when those 2 slots are used simultaneously, you get 8 and 8, A quad card requires 16. That means you can't use a video card. So what do? You use the onboard video, which is only 2 cores. We still got the CPU to go look at. We'll get to it. But I want to try to get through this stuff and keep it 1, 2, 3 to keep it tight. Okay, based on using the GPU, if the machine requirement is for content creation rendering, I would not use the internal GPU, which is 2 cores, 2 GPU cores, for rendering. Even though the Adobe formula does not speak to cores, it talks about count. It doesn't talk about the count of GPU cores. It talks about the count of CPU cores. But if the GPU can do 80% of the rendering, you're going to want a separate video card. So if you put a quad card in here, you cannot put a video card in that second slot. Scenario number 1, quad card, 16 lanes. Scenario number 2, if we put a video card on here, they could go in 8 lanes and it'll be fine. But no quad card. So if that's the case, use the top slot. The second slot could be used for a dual adapter. And yes, the third scenario for a dual adapter, let's look at that. What if we put a dual adapter down here? Well, we can't. It's only 4 lanes. So in the scenario, which would actually be scenario number 4, and I'll go take a look at the specs and we'll see how that plays out. But the Xpander-Z card has to go in that slot. It uses 8 lanes. So if you're going to use the machine as is, as shipped, you put your video card in here, it uses 8 lanes. And Joey asked me, he said, in that scenario, how do I know if my video card is using 8 lanes? Well, the best test I know, the easiest, is GPU-Z. I've got a screen. If I think of it when I get to it, I'll bring it up and I'll show it to you that I got from Joey that verifies that information. But to reiterate, if you use the machine as it ships, no quad card in number 1, so you put your GPU in number 1. If the GPU is in number 1 and you put the dual adapter that comes with it, which is PCI Express 5, remember, now you've got 3 drives that can be PCI Express 5. So depending on the scenario of the software you're using, where you've got your C drive, boot drive, operating system drive, application drive, will be drive 1C. It can be running at, we expect there's going to be 3 iterations of these drives, 10,000 megabytes. The third will probably be 15,000 megabytes, which is what the spec is for PCI Express 5, M.2 NVMe. And the second iteration, which will be in the middle, will be somewhere in the middle of that on speed. Okay, when we go to chipset lanes or when we go to PCI Express 4, those drives, 3 different generations, would top out at about 7,200 megabytes. So when you're talking RAID to the CPU, that's one issue, but I wouldn't RAID what's in the CPU with what's in the chipset. One, there's going to be some issues with latency, but more importantly, you got a difference in a 10,000 megabyte drive, 10,000 megabyte per second drive in a throughput, which is burst mode, versus half that if you were at 15, versus, let's be specific, a 7,200 max. PCI Express 4 can be first, second, or third generation. 5,000, 7,000, or about 7,200 read and write for third generation. So to reiterate, what's in the CPU and what's in the chipset, I wouldn't RAID those 2 together because of that PCI Express 5 versus PCI Express 4. And as we look at the fourth scenario, let's go back to that. This is really the key in shared versus dedicated resources. So video card up here, 8 lanes, Xpander-Z in here, which would be the fourth option in the second slot for 2 drives. That gives you these 2 drives plus this one drive over here, which is PCI Express 5, M.2_1. So you'll have your 3 drives running PCI Express 5 if you choose in a 3-drive environment, so that you have, to reiterate, operating system, C drive, applications. The other 2 drives, depending on your configuration, could be swap. I'd leave swap on C, but that's a choice. Usually the second drive is more for a scratch drive, and that third drive would be your data drive. Your scratch drive would be drives where you might do your rendering, but rendering does not really have much to do in terms of audio or video. And since we focus on video, this would be a good machine, I think, to go either for audio as a digital audio workstation or for video rendering. You want to put in your one primary video card, since that can do 80% of the rendering. Then you've got your option for 3 drives, 2 of them on that card, all PCI Express 5. Then those other drives, how those are allocated, we'll get to it. Right now we're dealing with CPU. Okay, lanes. 16 lanes plus 4, so we're talking 20 plus the other 4, that's 24. And if we take 4 more for those other ports, then we're talking 28. And then you got the 4 lanes that go down that downgrade to PCI Express 4. That's how we get our 32. So pretty simple math. But I really should stick to what they tell us. And we're going to go look at the CPU in a minute and account for all that. And this port which is 10 gigabit USB-C, that is the port that would be, to reiterate, that's the optional port we're talking about that you won't use if you use the third slot. That's the port you're going to use optionally internally to get video out, and then that's your other USB-C port. So number 8 is a USB-C 20 gigabit, and then number 8 is on a separate chipset, shared resource. Number 9, that's your 10 gigabit display port, which is out of the CPU. And the number 10, that's also a 20 gigabit USB-C port. So there's that optional angle port. There's the middle port we were looking at. And here's your other USB ports, 10 gigabit. So that third connector on the back, 20 gigabit optional, 10 gigabit with DisplayPort, and 20 gigabit. So the other port out of that back panel has to be coming off the chipset. It can get confusing, so we'll look at chipset number A. What's curious is the Marvell AQC113 10 gigabit right there, 4 lanes PCI Express 4. Now you notice here, everything through the chipset is PCI Express 4. The lanes that connect the CPU to the chipset are CPU lanes downgraded to PCI Express 4 for that primary chipset A. And everything that goes through chipset B connects to chipset A before chipset A then connects to the CPU. So if we have 8 usable lanes, if we read their key legend according to the top down, there's 4 lanes and there's 4 lanes. That's 8. There's 4 lanes. That's 12. And then here's 2 more lanes, 13, 14. And if we add up all these other ports, which these are probably sharing lanes, that should get us to a total of 16 lanes, 8 usable. And if we've got 12 usable in the second chipset, there's another AS Media chipset. There's 2 M.2 drives, 8 lanes for 4 lanes each. So 8, 9, 10, 11, 12, plus 4, which is 16. There's another AS Media chipset, and that's giving us those connectors to the front for the USB 3. Anyway, you get a general idea of how the lanes allocate. Now here's AMD's link on the Ryzen 7000 processor. We're going to go to specifications, and that will take us to the 4 different processors. Okay, we're looking at the Ryzen 9 7950. So what we're going to look at now are lanes for the CPU, and AMD gives us 2 numbers. These are native PCI Express 5.0 lanes. The total is 28, which we, as we reiterate, said our actual total was 32 based on CPU lanes to chipset. So 28 lanes within a CPU, 24 usable lanes, and we went through the math how to allocate that, 16 lanes plus 4 more to see how that plays out. Or in the case of 8 and 8, which is 16. Anyway, 16 plus the 4 plus the 4. So we get our either 24 lanes or 28. Now, one question we've been asked before, what's the big difference in the 2 chipsets, specifically the X570 versus the new one? 2 primary changes that are different. One, you're getting, I guess like 3 changes. You're getting PCI Express 5, and you're also getting, and I'll keep them separate because somebody fussed about that, you're also getting DDR5. But number 3, as it relates to this page, we're getting 4 more lanes from the CPU to have more stuff with more bandwidth, higher speed, which is nice. Not enough, but it's still more than what we had. Now the information we need, according to the socket, which is the AMD socket AM5, we'll take a look first at chipsets, and that's 4 chipsets. The X670E is made up of 2 of these chips, and those 2 chips combined give us the X670E. And what's the difference in the 2? The X670E gives us the most of everything. There's a definition. PCI Express 5 is the big deal. Okay, now as we reference this for the BIOS manual from MSI, this is the MSI AM5 Platform Manual, which means that one manual supports not just the X670E, but it supports everything on the AM5 platform. So it's a very generic, the most generic BIOS manual we've seen yet. And the link was embedded, again to reiterate, inside the Motherboard Manual, which there ought to be a separate link for that, but it is what it is. And there's some terms we want to look at as it relates to being able to bifurcate those slots, because it's going to be required for the Xpander-Z, but it would be required if in scenario 1 you try to put in a quad card to give you 4 M.2 drives. Not practical, but doable. And there's nothing here before we go to that manual that says anything about lanes. So we have a link into Tech Power Up that gets into the lanes for the CPU, and this was published before the specs AMD put out for us. 28 total lanes, and the first 16 lanes for a slot, or they can be split, which is what we're seeing on this board, into 2 8-lane slots. And the requirements only enforce PCI Express 5 on the X670E motherboards, to reiterate that, which means PCI Express 4 will be applicable to lower cost motherboards. So you got the skinny on that. Now the next thing we need to look at, and the reason we're here, is about chipset. Okay, 8 general purpose lanes. Some boards will implement Thunderbolt 4, Maple Ridge, or the AS Media chipset that we talked about, which is not on this board, which this board will not support. Because to be able to have USB 4 or Thunderbolt 4 support is going to require a multi-pin header. And as we've seen on the 2 Gigabit boards we've looked at, we've been through a 5-pin header. We went then with Gigabit to a 5-pin, 3-pin motherboard Thunderbolt header. Now, because of the chipset, which is probably going to be using, which is an add-in card, which will probably be using the AS Media 4242 chipset, which is not out yet. When that chipset comes out, 4 Gigabit, that add-in card, which is probably a year away, is going to require a 5-pin header. Okay, we don't have motherboard headers on here, and that enables BIOS compatibility, BIOS support, specifically to set 2 memory apertures for devices so when they connect, they stay connected. They don't connect and disconnect. That's very frustrating. And there's other things that get set, but those are the 2 primary that I'm talking about. So I want to reference this because this is a really good article that we'll probably be seeing and referencing a lot more, because the next part of this is about chipset lanes. And I'm going at this a little bit different than the others based on the questions that we've had for understanding. Okay, as this article covers it, it's called the Promontory 21, and that terminology is used by ASRock, which we'll see in the next motherboard block diagram for the motherboard by ASRock that we're going to cover based on a question. And it says a total of 16 lanes. And here on the primary chipset, another 4 lanes are used up, leaving 8 usable lanes on the primary chipset. And the other information here, the secondary chipset has 12 usable PCI Express lanes. So we point this out so you can count and reference how this adds up. 24, 28, we had 32. These 2 combined, we get 32 based on 16 and 16. And with 8 on the primary and 12 on the secondary, you can kind of see as we look at the block diagram where the lanes are at. I've looked at these block diagrams, and how many times can you count those numbers I've just mentioned? 100 times. How many times can you do that before it all just goes to jelly? So I like to know what they say, but I like to know what the total is, and the numbers are there. But it's curious to see how it plays out. The point of it is, on the consumer desktop motherboard, there's not enough lanes. When we built this high-end desktop, and we had the ability to install the devices we have in this motherboard, such as, even though we have 4 16-lane slots mechanically, the physical size, these are actually 2 16-lane slots electrically, 2 8-lane slots electrically. And on this second 8-lane slot, we're using 4 lanes. 4 lanes we lose, but that's where our Thunderbolt 3 is at, and we have a connector to the motherboard to tie the motherboard and this controller card together for BIOS support. And that support we're not going to see on the MSI boards. None of them that I've looked at have any of that on there, which is kind of fascinating. So as we put out a separate video about 20 gigabit USB-C, 20 gigabit USB-C is the easiest to implement because it doesn't require any extra connectors. It requires a 4-lane slot. And that third slot for a scenario of a third add-in card could be that because there's 4 lanes there. Some of you have asked about capture cards. If you put, say, a 1080 capture card, it only requires, I believe, 2 lanes. If you put in a 4K capture card, it requires 4 lanes. All the capture cards that require 2 lanes or 4 lanes are PCI Express 2. But these are going to be, according to what we're reading, PCI Express 4 lanes, so you got lots of bandwidth. My contention would be a separate video, would be to use something like a Blackmagic device, external, on a USB-C port. Now, as we look at these USB-C ports, let's look at the block diagram again. As we look at these connectors, because we've settled on the fact that we're going to have our GPU in an 8-lane slot if we use the Xpander-Z card, which requires 8 lanes. And we can use CPU-G to verify that lane usage. Okay, this third slot, if we choose to use it instead of that 20 gigabit port, which is the one on the left on the angle on the I/O panel, if we use this for 4 lanes, that's where you put your capture card because it's a dedicated slot. Dedicated if you use it for that. Otherwise, that's where you get 20 gigabit. Focusing on what we can get out of USB-C period, if you need that one display out because you don't want to buy a video card right now, that's where you're going to be getting it out of that middle USB-C port on the back I/O panel. And the third port on the back, apparently, is coming out of the chipset. My guess is chipset A, and that third port, 20 gigabit, will be coming out of that port right there. So 3 ports out the back, to reiterate, number 1, optional. Number 2, and this is going to relate to a pro audio interface. Based on latency for CPU, chipset, or chipset, I would probably want to put the pro audio interface out of USB-C port on the CPU based on latency. But if that's the case, then I'm not going to be able to use the video out because that's the port that we would want to put it on. Otherwise, I've got to put it on a 20 gigabit port, and the one 20 gigabit port out of the CPU is on a separate chipset that would conflict with that third slot. So again, you've got all these connectors, but you can't use them all. You have to choose. And you have to decide. Remember, you list your 5 and prioritize. So then your Pro Audio interface, because your video card will be on the second location being out of the primary chipset. So it comes out of the back I/O panel. So it's all these give and takes. I think this is probably the best motherboard layout, but I got some more stuff to share. But it's all a matter of change one thing, and that changes everything. Okay, I want to take you now and show you some information on the Xpander-Z. I probably ought to start from the top and work down with memory, but since we're on the Xpander-Z and we're talking about M.2 drives, right here it shows if you do a search on Xpander-Z, this is showing on page, looks like 41, but I'm not going to count it by page. Just to reiterate, search for the term. To reiterate, you're going to be in that second slot. Identifies it here, PCI Express _E2, and that's your 8-lane slot. Okay, now let's go to DIMM slots. The question about using one DIMM, and this is specific, but they don't point it out, but I asked Joey to identify and verify. If you're only going to start this with one DIMM, then right there it shows you DIMM A2 is the DIMM you want to go with. If you're using two DIMMs, it's DIMM A2 and DIMM B2. An issue we always like to look up is about bandwidth, and we just did a search on bandwidth. Can't refer you to page numbers because the count doesn't come out right. Anyway, the USB 20 gigabit C port from the AS Media 3241, which is out the back, that port and PCI Express _E3 slot share the same bandwidth, which to reiterate is what we saw in the block diagram. And as such, to reiterate, using that slot, that USB port would be disabled, that 20 gigabit USB port. Now let's take a look at the MSI Bios Manual for the AMD AM5 series. Yeah, it covers all of them. And the terminology you're looking for, you can do a search just for PCI, but what you're looking for is PCI_EX lanes configuration. And to reiterate, PCI Express lanes configuration is for the MSI M.2 expander, Xpander-Z, or other M.2 PCI Express storage card adapters. The options in this item will vary with the installed processor. And Joey was able to grab us an image since he has the motherboard and has the BIOS. And what you're looking for under settings for PCI Express lanes for that slot, which will be right below the resized bar, is PCI_E1 lane configuration. And right there is the 4x4x4x4. So for that primary slot, it supports full bifurcation. So as we're looking at the block diagram, we're talking about that slot, the primary slot, supports full bifurcation, 4x4x4x4. And if you need bifurcation for a quad card, it's supported, but then if you want to put a video card in there, you can't because you want 4 drives, and each drive has to have 4 lanes, 4x4 is 16. Anyway, to reiterate, that first slot can be fully bifurcated. Now, if that first slot can be fully bifurcated, the second slot, which is an 8-lane slot, can be bifurcated for the Xpander-Z card, so you have 2 M.2 NVMe drives on that one slot, 4 lanes and 4 lanes. But those 3 drives, one on the CPU out of that primary M.1, and the other 2 on that quad card, are all PCI Express 5. So, as Joey said, you can get all the drives on here, all 6, but you got some give and take. You have to decide what's more important. Now, Joey's got a video card in there, and he had a concern, to reiterate, because of the thickness of the backplane with the GPU, when the Xpander-Z is in there because they're close. So that's going to be a concern. Now, if he's got an RTX 3090 in there, that by default would be 3 slots wide. And I've seen pictures of one of the GPUs he's used, which was liquid cooled, so he had a little bit more space, but he didn't have the quad card. He didn't have the dual adapter in there. So no quad card, video, primary slot, which is scenario number 2, so that you can then have, which would be scenario number 4, putting the dual adapter in there, the default configuration. So quad card is one option, video card is the second option. Third option would be an add-in card in the third slot, which is 4 lanes, it'll work. And the fourth option, as we go through this monkey mess, is about if you wanted to use the dual adapter, it'll work. So 4 different add-in cards. I hope I've made that clear, and I've explained that based on the questions that have been asked, completely different than what we normally do. I hope it provided clarity, and I hope it was simplicity. But the 3 different scenarios, 4 scenarios, so you understand what you give and what you take all the way down the line. There's ramifications on everything. A good motherboard, interesting motherboard for the consumer desktop motherboard. And of the other 3 we've looked at, this being number 4, I like this the best. I'm curious to see how these others are going to play out, because now we've got something that, as we've done this overview, that has set the bar for allocating resources in the right direction as it goes to content creation. And we've tried to cover as many questions as we could based on the way they were asked, which sometimes feels like I'm going down a rabbit hole. But the goal is to keep it simple, make it work, and that's what we were about. So nice motherboard. Can't really search by page numbers, search by terminology. A couple things with some final thoughts that Joey shared, and I'll put it up on so we can read it, see it looking at me. For the MSI X670 ACE, and these are Joey's notes, using a 7950 G-Skill Trident-Z, and I'll put up the link to the specs for the memory. And to reiterate, he was going to try some other memory later using Samsung B-Die. He had a FireCuda 532 terabyte. Likes. So many likes, but he'll name a few. His most favorite board he's owned in the past 40 years. That's a big statement. M.2_1. Easy to get to, don't have to remove the GPU. Easy to open, insert, and close. It's because of those connectors instead of using screws. Can run all 6 M.2 drives. 2 physical BIOS switches. Programmable reset button provides 4 different options to choose from. 60-watt USB fast charge to the front. MSI service was great when you had to call them for some details. Pump headers are 3 amps. All fan headers are 2 amps. The Marvel 10 gigabit LAN. And yes, to reiterate, supports full bifurcation. Can boot with 1 DIMM, we verified that. And which one? Can use all 3 PCI Express slots by 8 by 8 and by 4, and all to the CPU. Things he'd like to see improved. Number 1, a GPU release button like Asus and Gigabit have. Number 2, MSI's smart button to have the option to enter the BIOS like Gigabit does. Number 3, as with all new motherboards, the first initial boot to calibrate RAM timing is long. After that, it's good to go once it's learned. M.2s. No noticeable latency on any of the M.2s, even the ones connected to the chipset, which is amazing. Testing M.2 slots, Crystal Disk Mark 8, FireCuda 530, a 2 terabyte Generation 4. And I just asked for the basics. He's going to list sequential read and write speeds. And I'm giving you the numbers he's given us. M.2_1, a Generation 5 from the CPU, but remember that's still a PCI Express 4 drive. Those are the numbers. Those are the temps. M.2_2, Generation 4 from Chipset A. M.2_3 and M.2_4, Generation 4 from Chipset B Southbridge. All 3 M.2s on both chipsets ran the same speeds. There's the numbers and there's the temps. And the M.2_2 temperature is mostly under the GPU. The M.2 Xpander-Z dual card performed the same as the M.2_1, also performed the same in PCI Express_2 or PCI Express_3. If in PCI Express_2, the GPU in PCI Express_1 becomes by 8, even with only 1 M.2 on the card. If in PCI Express_3, the GPU in PCI Express_1 stays by 16. Just to reiterate the facts of what we know to be true. Card stayed at 27 degrees Celsius with onboard fan on and 31 with the fan off. Thanks, Joey. So I want to thank Joey for asking the questions that he did and for helping us to put this video together with information that was more than just an overview, but some of the review questions that Joey has shared with us. So welcome. This is BuildOrBuy. My name is Gil Boyd. Thanks for joining us. We'll look forward to seeing you next video. We're out.